B.Sc Physics Semester 5 Paper number 13A Solid State Physics Unit 1st Crystal Structure. Dear student, welcome to all of you. In this period, we have to study crystalline solid and non-crystalline solid. Today, we have learned about crystal structure. We also have studied crystal structure in chemistry. What is importance of solid state physics? The solid state physics is the branch of physics dealing with physical properties of solid, particularly crystals, including the behavior of electron in this solid. Matter consists of one or more element or their chemical compound exist in nature in the solid, liquid and gaseous state. As the atom or molecule in solids are attached to one another with strong force of attraction, the solid maintain a definite shape and volume. The solid may be broadly classified as into two parts. First is crystalline solid, second non-crystalline or amorphous solid, depending upon the arrangement of atom or molecules. Number first, crystalline solids. The crystalline state of solid is characterized by regular or periodic arrangement of atom or molecules. If the atom or molecule are arranged in some regular fashion, then it is called as crystalline. Second point is most of the solids are crystalline in nature. Third, energy release during the formation of an ordered structure is more than disordered structure. Fourth, crystalline state is also low energy state and prepared by most of the solid. The crystalline solid may be subdivided into two parts. First is single crystals, second polycrystalline solid. Number first, single crystals. The periodicity of the atoms extends throughout the material. For example, as the case of diamond, quartz, mica, etc., isn't it? Second part is polycrystalline material. It is the aggregate of number of small crystals with the random orientation separated by well-defined boundary. The small crystallines are called grains and boundaries are grains boundary. Periodicity of individual crystals is interpreted at grain boundaries. Polycrystalline form of a material may be more stable compared with its single crystal form. For example, most of the metal and ceramic exhibit polycrystalline structure. The definition of amorphous is when the atom or molecule are arranged in a regular fashion, then it is known as amorphous. If a crystal is a solid composed of periodic array of atoms, then we shall discuss on non-crystal or amorphous solids. We have to distinguish between crystalline solids and non-crystalline solids. The first point is in case of non-crystalline solids are characterized by completely random arrangement of atom or molecules. Second, periodicity at the present extend up to a distance of few atomic diameter only. These solids exhibit short range order. Third point is atom does not get sufficient time to undergo a periodic arrangement. For example, glass is an example of amorphous material. Second, most of the plastic and rubbers are also amorphous, isn't it? What is crystallography? Why you have to study crystallography? First of all, we can define the crystallography. The science which deals with the study of geometrical forms and physical properties of crystalline solid is called crystallography. The study of crystallography is necessary to understand the strong correlation between the structure of material and its physical properties. The present chapter deals with some of the basic concepts of crystallography which are fundamental to study of solid state physics. Last, in summary of crystalline solids and non-crystalline solids, we have to differentiate between these solids. First is, in case of crystalline solids, they are characterized by regular or periodic arrangement of atoms or molecules. In case of non-crystalline, they are characterized by completely random arrangement of atoms or molecules. Second point, energy released during the formation of ordered structure is more than disordered structure. In case of non-crystalline solids, these solids exhibit short range order. Third, low energy state in crystalline solids. There is no energy state. Fourth point is periodicity of atom extends throughout the material. In case of non-crystalline structure, extend up to distance of a few atomic diameter only. Some example in case of crystalline solids: diamonds, quartz, mica, metal and ceramic exhibit the single and polycrystalline structure. In case of non-crystalline solids, the glass, plastic and rubbers are also amorphous. The next point is the crystal lattice and translation factors. First of all, we can define the point lattice or space lattice. What is meant by point lattice or space lattice? We define an arrangement of infinite number of imaginary points in three-dimensional space with each point having identical surrounding is known as point lattice or space lattice. We have the arrangement of atom in a crystal. It is always convenient to describe the arrangement of imaginary point in space which has definite relationship with the atom of a crystal. This set of imaginary points form a framework on which the actual crystal structure is based. The term identical surrounding means the lattice has the same appearance when viewed from a point R in the lattice as it has when viewed from any other point R dash with respect to some arbitrary origin. This is possible only if The lattice contains a small group of points is called pattern unit, which repeat itself in all directions by means of a translation operation T. It is given by T is equal to A n1 plus B n2 plus C n3. This is the first equation. In this equation, where n1, n2, n3 are arbitrary integer and the vector a, b and c are called the fundamental translation vector. Thus, we have r dash is equal to small r plus capital T. That is equal to, by using equation 1, we have r dash is equal to r plus a n1 plus b n2 plus c n3. This is the equation second. In first point, in perfect lattice, equation second hold good, that is, point r dash can be obtained from R by the application of operation of equation 1. Second point is, in an imperfect lattice, it is not possible to find small a, b and c such that an arbitrary choice of n1, n2 and n3 makes r dash identical to small r. In this case, we have to define some part. It is taken about point lattice and space lattice. We have to study the next point. We have to learn about unit cell. First of all, we can define unit cell. How to define the unit cell? The first definition is the parallelogram formed by the translation vector may be regarded as building block for constructing the complete lattice and are known as unit cell of the lattice. The unit cell may be defined as the smallest unit of the lattice, which on continuous repetition generates the complete lattice. This is the definition of unit cell. Both the primitive and non-primitive translation vector may be used to construct a unit cell. We have to differentiate the primitive and non-primitive translation vector may be used to construct a unit cell. A unit cell named as a primitive unit cell or non-primitive unit cell. First, we shall discuss on primitive unit cell. Number first, it is the smallest volume. Second, all the lattice points belonging to primitive cell lie at its corner. Third point, therefore, the effective number of lattice points in a primitive unit cell is 1. This is the information about the primitive unit cell. Second, non-primitive unit cell may have the lattice point at the corners as well as at other location, both inside and on the surface of the cell. Second point, effective number of lattice points in a non-primitive cell is greater than 1. The primitive cell can also be constructed using the following procedure. In this case, there are two types of unit cell. First is primitive unit cell and second is non-primitive unit cell. In this figure, ABCD is a primitive unit cell and EFGH is non-primitive unit cell. Both the lattice point or primitive and non-primitive, we have to differentiate between these two unit cells. Primitive unit cell is the smallest unit cell and non-primitive unit cell is greater than the primitive unit cell. This is the main difference between this primitive and non-primitive unit cell. Let us we have to discuss on primitive cell. Can also be constructed using the following procedure. First, connect a given lattice point to all the nearby lattice point. Second point, draw normal at the midpoint of the lines connecting the lattice point. What is a Wigner-Sage cell? We have to define the Wigner-Sage cell. The smallest volume enclosed by the normal is required primitive cell. Such a cell is called Wigner-Sage cell. From this figure, construction of Wigner-Sage primitive cell, the fundamental translation factor or crystallographic axis is given by capital Phi is equal to mod of A dot B cross C, where A comma B C are the fundamental translation factor and the primitive cell having the smallest volume should be chosen as the conventional unit cell. In summary, we have to distinguish between the primitive unit cell and non-primitive unit cell. First point is, it is the smallest volume cell in case of primitive unit cell. In non-primitive unit cell, greater than the primitive unit cell. Second point, all the lattice points lie at its corner in primitive unit cell. The lattice point of the corners and other location both inside and on the surface of the shell in non-primitive unit shell. Third, effective number of location or lattice point is 1. The effective number is greater than 1 in non-primitive unit cell. This is the short information about primitive unit cell and non-primitive unit cell. In this period, we have to study the 3 points. First point is the crystalline solids and non-crystalline solids are amorphous. The second point is the crystal lattice and translation factors. In this article, we have to define the lattice point or space point and translation factors. T is equal to AN1 plus BN2 plus CN3, and the other equation, second equation is R dash is equal to R plus T. The third point is unit cell. We have to define the unit cell, and unit cell consists of first is primitive unit cell and second is non-primitive unit cell. This is the short introduction about the crystal structure. Thank you very much.